In this question, this circuit is given to us, and there are 4 points A, B, C, D given to us, and we have to find the value of VA minus VD. That is, we have to find the potential difference between this point and this point. So in this circuit, if we look carefully, we have two loops. So we can find it by using Kirchhoff's voltage law. So for this loop, let us say this is the direction of I1. I1 current is flowing in this loop in clockwise direction, and similarly I2 current is flowing in this loop in clockwise direction. This is 1 ohm resistor. So here, if we use KVL using Kirchhoff's voltage law, in first loop, in this loop, we can write the equation as 2I1 plus 3I1 minus 10 equal to 0. So because we are entering the negative terminal, so minus 10 and equal to 0, so it will be equal to 5I1 equals to 10, or we can write that I1 equals to 2 amperes. So this will be our first equation. Now here we notice that at this junction, this branch is connected to this junction. So if I1 is going in this direction, in downward direction as we have taken, then at this junction it should be divided into these two parts, but it is not dividing because we know that Kirchhoff's voltage law is applied only on the closed loops. So if I1 is the current originating from this battery, then the same current should be going inside the battery. This is the law of conservation of charge. We cannot violate this law. So I1 is originating from this battery, but if it gets divided here and this branch is not coming back to this branch, it is not forming a closed loop, so that means the current here will be entering the battery will not be equal to I1. So this means there will be no current in this branch, because as the current in this branch goes, then it will violate the Kirchhoff's law and it will also violate the law of conservation of charge. So there will be no current flowing in this branch. So similarly, if we use KVL in second loop, in this loop, so again we can write the equations 6I2 plus 20, as we are entering the positive terminal, so plus 20 plus 4I2 equals to 0. So solving this, we will get I2 equals to minus 2 amperes. This will be our second equation. So now we know the values of I1 and I2. Now we have to find the potential between these two. So let us say that our path starts from here, VA, and we go like this, and we know that in this branch there is no current flowing, but there is a battery connected to this branch. No current, neither I1 nor I2 will go in this branch, because then it will violate the laws. So no I1 or I2 will flow, but there is a battery, so it will add to the potential, although there is no current flowing in this branch. So there will be no potential drop across this resistor, but because of this battery there will be some potential across this branch. So we know that in the direction of current the potential decreases. So we can say that at A the potential is positive, because we are taking the starting point as A, so potential is positive, so we will write VA. Then here the potential drop on this resistor will be lesser than the potential at A, because we are moving in the direction of current, and as we are moving in the direction of current the potential will decrease, so it will be equal to minus 3I1. Then here when we are moving from B to C, the battery will gain the potential will be gained because of this battery, so again the potential will become high, so we'll write plus 4. Then here we are moving in the direction of I2, moving in the direction opposite to I2, so and the potential is decreasing, so both minus minus will become plus. We are moving, the one negative sign will be because we are moving in the direct opposite to the direction of I2, and one negative sign will be because the potential here will be lesser than the potential at 4-volt battery. So both negatives will multiply and get us positive, and we'll get potential of plus 4I2 here. then VD at this point, since it is connected at the negative terminal of this battery, so here the potential will decrease. So we can write minus VD, and all of them will be equal to 0 by Kirchhoff's law. So VA minus VD, and we take all these quantities on this side, this will be equal to 3I1 minus 4 We have the values of I1 and I2 here. So substituting these values, we have 3 into 2 minus 4 into minus 2, and we'll get this. So VA minus VD will be equal to 10 volt. So this will be the answer to this question.